Manchester, birthplace of the Industrial Revolution, home to the father of atomic theory, John Dalton, and the father of modern computing, Alan Turing. From Karl Marx to the contraceptive pill, from the co-op movement to the first hard drive, this city has been a constant source of new ideas. And now, well, Manchester is the centre of a new revolution, another globally significant, game-changing black swan event, and it's called Graphene. And it was isolated here in the physics department at the University of Manchester. It's so extraordinary that in 2010, the scientists who made it were awarded the Nobel Prize for Physics. Now, in a story of serendipity and free thinking that rivals any in scientific history, these geniuses did what no one had done before and isolated graphene, creating the first ever man-made material in 2 dimensions. Graphene has almost limitless potential. It's so light and so thin, but it's strong and it's dynamic. The visions, the predictions of sci-fi writers and tech gurus are finally within our grasp. It is a carbon sheet, 1 atom thick, but 200 times stronger than steel. It's the lightest, most conductive man-made material on Earth. It can be used for DNA sequencing at a nanoscopic level. It can be programmed to attach itself to specific cells, like cancer cells, which will revolutionize medicine. It's almost completely impermeable and could be fundamental to the storage and transport of fuels of the future. It stretches, it twists, it rolls to create bendable devices, not just touchscreens, but flexible, transparent components. Graphene devices will be able to carry electricity more efficiently.
A graphene string that is thinner than human hair could support the weight of a grand piano.
It could bring us the revolutionary possibility of electric planes.
In just a few years, we could all be wearing
graphene-laced smart clothing. We could be writing, tattooing, painting electrically conductive reactive inks. The list is endless. In the future, graphene's magnetic properties could bring particle accelerators into our laboratories instead of out on mountain ranges. It could be like having CERN on a desktop. And it is all because of graphene. And it was discovered here at the University of Manchester lab in a city that has always encouraged new ideas. The material of the future in a revolutionary city. It's a free exchange of ideas in a city of innovation. I mean, wow. See, for this city, it's not so much a question of where do we start. It's more about where do we go next?